And there's some kind of complementarity between having no space-time and having space-time.
That which is dimensionless gives rise to all dimensions. And that's a very difficult concept for most people, because how do you imagine something that has no dimensions, that has no location, that is timeless, that yet without which there would be neither space-time nor any dimension. And now we do know, I think, most people will concede that the universe at the most fundamental level is non-local, even though our experience of the universe is local.
Yeah, so I'm definitely all for non-locality. I mean, so when you look at something like the double slit experiment, which is a macroscopic phenomenon as well, you're seeing this weird quantum stuff. You can do this experiment. Hitachi does a good job at it. And in this experiment, you really see individual electrons landing on the other side of the screen, and then eventually you see a wave-like pattern developed.
Correct.
How did these other electrons know within 30 minutes that to form a wave pattern collectively? So you're seeing both the wave and the particle-like thing. And the best theory and I looked and I thought very deeply about this, that really does a good job explaining that is the Broglie-Bohm interpretation.
Correct.
Which is an intrinsically non-local hidden variables formulation, which is completely consistent with the Bell inequalities.
And yet actually gives good mathematical predictions,
Oh,
right?
absolutely. It certainly does. It actually does a great job, too, in quantum cosmology. Mm-hmm. You can talk about the wave function of the entire universe. So the wave function describes the quantum entity. You can actually describe the entire universe with a wave function. This concept was first introduced by Stephen Hawking and Jim Hartle. So it's not that crazy that there might be a wave function in the entire universe. And then you can ask yourself, well, how did the universe separate into space-time and the stuff that's dancing in the space-time? And if you accept the Bohmian interpretation of the wave function of the universe, it gets around some of the conceptual and mathematical problems.
The pilot wave that guides the behavior of particles.
Yeah, a brilliant Brazilian physicist, whose last name is Pinto Neto, has been developing this idea. And it's beautiful stuff.
Mm-hmm. So now personally, do you think that this stuff could be consciousness? Do you think the fundamental stuff is non-stuff?
I am very open-minded about these things. I mean, if you allow me to take off my physicist hat and put on my Stephon, the human being that thinks very heavily about how these things interface, I think it's a logical possibility, because we don't know what consciousness is. My friends that work in neuroscience, that's the last thing they want to talk with me about. It's consciousness.
Shut up and calculate, right? That's the mentality.
That's the mentality. But it's a there's a saying, I think it was Wolfgang Pauli, your theory is not crazy enough.
Yeah.
And I think that to really get to the bottom of reality in the cosmos, we might at some point, maybe some future generation, maybe one of my students will have the courage to really tackle cosmology in the face of the question of consciousness.
Mm-hmm.
Available on CuriosityStream. Watch premium factual shows at curiositystream.com.